This is the last section of Chapter 5, and what we're going to be doing is making some connections between sinusoidal functions and your instantaneous rates of change, or your IROCs. Now this is a great warm-up because we're not only going to look at sinusoidal functions and their transformations, but we're also going to link that IROC stuff into it. Okay, now I've actually already sketched both cycles of this function, and let's just go over really quickly how I did that. I have a sine function right here, and I'm looking at this and thinking, okay, vertical stretch by a factor of 3, and a horizontal translation to the right pi over 4. So let me show you my work. I use mapping notation, so I have the 5 major points of the sine function, the original in black, and then I did my vertical stretch by a factor of 3 in red by multiplying 3 to all of the y values. I also did in green my horizontal translation to the right by adding, okay, so opposite, pi over 4 to any of my x values. When I calculate all of my new points, these are going to be the 5 major points to the first portion of my graph. So they're going to be right here, 1, 2, 3, 4, and 5. All right, and I just joined those. Now since it asks for 2 cycles, I'm going to continue the pattern over here. All right, so there's my graph. That's the review of the sinusoidal functions part. Now the review of the IROC part. IROCs are just slopes. Okay, so I'm just going to be drawing a bunch of slopes and seeing where they're increasing and decreasing. All right, so what you're going to do is you're going to look at, let's say, half of a parabola. Those portions of the graph. So here, this is another half parabola. This guy right here is another half parabola, and so on. Okay, so why don't I just show you with this section right here. If I draw a slope or a tangent, this looks like a negative slope. I'm just going to make up a number, maybe like -10. Okay, and then I'm going to draw another one, getting closer and closer to the peak. Okay, so that minimum. That looks like a negative, but not as steep. So this one might be -5, okay, and then maybe -3. And then at the peak, it's going to be like 0. Okay, so if I look at all of those numbers again, -10, -5, -3, 0, all of those slopes are increasing. Even though they're negative, they're increasing, okay? So from 0 to, say, 3, oh, now it's positive. Okay, +5, +10. Remember, I'm just making up these numbers, but it goes from 0 to a very positive number. This section is also increasing. So you see, these two parts of the graph are increasing. So I just wrote down that answer right here, and I've got these numbers from my coordinates that I had before. Decreasing. Okay, let's look at the tops now. If I draw a slope or a tangent right here, that might be a positive slope of, say, 10, and then maybe 4, and then 2, okay, and then 0. So those numbers are decreasing in value. Even though they're all positive, they're decreasing in value. Now here is 0, and then -2, and then negative, I don't know, 6, -10, okay? So those are all becoming negative, more and more negative. So those are also decreasing. And that's why these sections at the top are going to be decreasing in value. It's very important to understand that these are round brackets because they don't include any of the zeros. The reason for that is because notice that there's some overlap in a different color right here. This is where the dot is neither positive nor negative. So you're not increasing or decreasing at that part, and therefore we don't include those numbers within the intervals. All right, so that was just a warm-up, but it does include everything that we're talking about. Now, this example has to do with just, it's just trig. We're dealing with angles here. It's not really real life. So here is a real life question. All right, so let me read the question to you. Example number 1. Larry loves a Ferris wheel. Okay, anyways, it's not written that great. Larry loves Ferris wheels. Okay, the Ferris wheel at the town fair is 30 meters tall and makes one rotation every 40 seconds. The Ferris wheel's loading platform sits 2 meters above the ground. So what we want to do is we want to finish the table, we want to graph it, and then we actually want to create two equations for them, one sine equation and one cos equation. So this question actually doesn't have to do with IROCs, but it just reviews our sinusoidal information, okay? So here is our Ferris wheel. We know that it's 30 meters tall, so the wheel itself has a diameter of 30, and that's why I broke it up into even portions of 15. Okay, one rotation is 40 seconds, so if you're loading right here at the bottom of the platform, 10 seconds later you're going to be here, 20 seconds is going to be at the very top, 30 seconds is going to be here, and then 40 seconds you're going to be at the bottom again. So that's what I have right here, which is one rotation. You also know you're 2 meters above the ground, so I've added this little 2 at the bottom, and that's going to help us with our calculations. So I want to fill out the rest of the table, and we're going to do that up until 120 seconds. Okay, so the very first one, at 0 seconds, you're loading right here. You are 2 meters above the ground. At 10 seconds, you're now at the first quarter, and you are this far above the ground. So that is the 15 and the 2 together, which is 17 meters above the ground. 20 seconds means you're all the way at the top now, so you are 15, 15, and 2, which is 32 meters above the ground. Another 10 seconds, so now you're at 30 seconds, you're back to 17 meters above the ground, and then at the full circle of 40 seconds, you should be right where you began, which was 2 meters above the ground. Okay, so finishing off the rest of the table, you're just going to repeat those numbers again. Now to draw something like this, what I did was I put one rotation, so this is 40 seconds, on the bottom of, where the x-axis is, and then since it goes up to 120 in the chart, I'm going to do those 3 cycles. You're going to plot your points, so this is one coordinate and then another coordinate, all right, and then you're just going to join them. So there you go, pretty easy to graph them once you figure out the table. The hardest part is creating those equations, so the sine equation and the cosine equation. I need a little bit more space, so I'm just going to zoom in a little bit. There we go. Okay, so starting off first, I usually like to start off these ones with the cosine graph, because if you think about it, this does have the cosine shape. I mean, normally what you see it like that, right? But it's still a cosine, it's just going to be flipped. So remember, this is going to be a negative cosine graph. Now let's start to analyze it a little bit. Your amplitude is going to be your max minus your min, and then divided by 2. So your maximum was 32, your min was 2, and then split in half, you're going to get your 15, which, if you remember, is your radius for the Ferris wheel itself. Okay, now your period. The period is going to help you to figure out your k value so that we can put that k value into the equation. The period, one rotation, was 40 seconds. So I'm going to put the 40 right there, and then I still have this portion of the formula. I'm going to cross multiply. Okay, so 40 times k is 40k. Underneath the 40 is a 1. 1 times 2 pi is 2 pi. And then I divided both sides by 20 and I reduced. By 40 and then I reduced. Okay, so our k value that goes into the formula is pi over 20. We also want to see if there is a vertical translation. So normally this graph would have been at 15 and negative 15 if you've stretched it by 15 times, but it's obviously not. I mean, you're all the way up at 32 and all the way down at 2. So what I'm going to do is I'm going to subtract the max and the amp to get my vertical translation. So the actual graph, after being stretched, has also been vertically moved upwards 17. Now in terms of a phase shift, I mean, like I said, the cos graph normally would look like this. And if there was a phase shift, it would have moved over, okay? But since the beginning is still on the y-axis, there is no phase shift, okay? It hasn't moved side to side. So if I put all those things together, it is a negative cos because it's flipped upside down. You have your amplitude, you got your k value in here, and then we're just going to put our x with no blue part, no phase shift, and it's going to go up 17. Okay, so a cos graph is easy to figure out. The sine graph, however, so notice that I've mapped out the portion of the graph that looks like a sine curve, is a little bit more difficult. The amplitude, period, vertical translations are all calculated the exact same way. So if I did a sine function, they're going to be exactly the same in that you have the same red, purple, and orange numbers. But the phase shift is different because normally a sine function should have started down there. But you've already said it goes up 17, so okay, great. Now I'm at 17, but notice that this green part is not overlapping your graph. You have to actually shift it over to this dot. So you shifted it to the right 10. Since you've done that, 10 to the right, you have to add that into your graph, or sorry, into your equation. So there you go, the sine graph adds an additional little part. It is not a negative because this is what the actual sine graph kind of looks like. It's not flipped. So I would say, you know what, personally, I find that the cos equation is a lot easier to figure out than the sine equation. But, I mean, you should know both just in case they ask you for both on a test. Okay, so IROC stuff really quickly. It's going to repeat itself over time. Okay, so the positives we've already discussed look like this, where you have positive IROCs, but in this case, even though they're positive slopes, this portion is decreasing because it goes from very positive to less positive all the way to 0. Okay, so it decreases towards a maximum. This portion is negative IROC, so negative slopes, but the negative slopes are increasing towards 0 when it goes towards the minimum point. Okay, I know that's really confusing. A lot of people have trouble with that. Now, the largest IROC, the largest, most positive slope you can have is actually right in between a minimum and maximum right here. Okay, so this is the highest positive, most positive slope you can get. The smallest slope that you can get, the most negative, is actually right here between a maximum and a minimum. Okay, so notice that they'll repeat themselves depending on what the period is, and they'll go on and on forever. So this is a question that you could see if we had some sort of a graph like this between this domain. Why don't we list out all of the largest IROCs and all the smallest IROCs? Okay, so what I would have to do is I would actually have to graph it first. You guys know how to graph it already, but answering the question, all of the most positive, the largest IROCs are going to be here. So any of these portions between a minimum and maximum. And notice that they are going to be, I mean, you can calculate them by knowing what the period is. So if you know what 1 is, you can add the period and you'll just get to the next one. Add the period again and you'll get to the next one. So that's what this is saying in red right here, and I've listed them all right there. This is just an arbitrary number that we came up with. We're just going to assume that it's a slope of 6. All right, so just like that, we're going to look at any of the smallest IROCs, which are from a maximum to a minimum. And again, if you already know 1 and you just add the period, you'll get to the next one. And just add the period again and get to the next one. So we've listed them all here as well, and we've given it an arbitrary number as well of -6. Okay, so these are questions that are IROC and sinusoidal functions separately, but also, I mean, we did a question as well of them together. Okay, so I know that it's a little bit tricky, especially with the IROCs, just looking at decreasing versus negative and increasing versus positive. Everyone has a little bit of trouble with it. Don't worry about it. If you have questions, just comment in the section below.